Welcome to the video tutorial for Unit 6, the mole, pages 6 and 7. We're going to get started right away. Alright, so the most important thing you have to do in this process is something that you've probably been hearing your teachers say a lot of, and that is box your givens, circle your unknowns. So before I do anything else, I want to make sure I do the boxing and circling. So right here, I am given 7.31 moles potassium. So I'm going to put a box around that. And I am looking for how many atoms. That's what I'm going to circle. From there, it is the same process to set up every single time, no matter what. Always start with what you are given. That is the best place to start. Given 7.31 mole potassium. Yes, I realize this takes a while, but at least in my class, you don't show the work, you don't get credit. And I know everybody else feels the same. So take the extra couple of minutes to set this up and set it up right. Because that way you will be able to follow the same formula every single time for the rest of the semester. Okay, so box, circle, write everything out. Always write your units. Your units show you what to do next. Because if I write down my units, I know I can just go down. I'm going to just go down mole K. Alright, the other reason we want to box and circle is because that also helps us figure out what to do next. I'm looking for atoms. Okay, so that's what I'm going to put up here. Alright, this is where I'm going to throw in my conversion factor because you know and I know that 1 mole is equal to 6.02 times 10 to the 23rd atoms. Because I did my setup correctly, these will cancel out, and so I just need to multiply on top in order to get the correct answer. So, you can get your calculator and enter that in there. 7.31 times 6.02. Remember to use that EE key or exponent key depending on your calculator. Do not try and enter 10 with a caret or do anything weird. Use either an EE key or a second EE if you have that, or your calculator has an exponent function. Okay? That will let you just skip a bunch of steps and it will make sure your exponents are done correctly. See? And then I'm just going to put in my 23. And that's it. No 10, nothing else. Hit enter, and that gives you your answer. So we aren't teaching you the rounding rules here in this class, but I'm going to say pull out to about 3 places. Most of the time that will get you to where you need to be. So if I pull that out to 3 places, my answer is going to be 4.40 times 10 to the 24th. Remember that E means times 10. Alright. That could also go in there. Either way. Next problem. Again, box and circle. What is the mass? So I don't know that. That's my unknown. If this is my given, 3.62 mole water. See, take that time, write everything out. Write out your units, just go down. I'm going to drag down that unit. Okay, and just like before, I want to think about what I'm trying to get to. I'm trying to get to mass, okay? So 1 mole is going to be equal, not just to this, because this is asking me about atoms, but on this one I'm getting to mass. Remember, moles are more than one thing. They're just an amount, like a dozen is an amount, okay? So I can be talking about amount in terms of particles, or I can also be talking about amount in terms of weight, okay? So there, you're going to need to look on the periodic table. We're talking about weight, which is what mass is, and you look on the periodic table. I need to figure out how much 1 mole of water weighs. I'm going to do that by looking at the periodic table. Okay, so the mass of H is 1.006. Okay, 1.00, or that says 1.008, I'm sorry. 1.008 and I have 2 of them. That's the hydrogen plus O. It's because water is H2O, right? 1 water weighs 15.999. All right, so throw that into your calculator. And the molar mass of water is 18.015 grams. Be sure that you are reading the question. Some of you are going to be like, why can't I put Avogadro's number? Because it's not asking about the number of atoms. It's asking about the mass. You need to read the questions carefully in order to set them up right. Alright, from there, I can just solve it by multiplying what is on top. I'm going to multiply 3.62 times 18.015. And my answer, again, you can probably just take it out 3, you have 3 digits there. So I'm going to say 6.5.2 grams. 65.2 grams. And that is my answer. You need to include your units, which I did not do in that last problem. So I need to write that in. Atoms, that's my unit. Okay, so we'll go ahead and make that a bonus point. Plus 2, write your units. Write units. So put a little star on there. Write your units. You will get those 2 bonus points, because that's very important. Alright, next problem. A sample of 3.42 moles of strontium is made of how many strontium ions? Again, box and circle, box and circle. This is my given, and I want to figure out how many atoms are in there. That atoms should tell you right away. I'm not needing to figure out the molar mass like before. Okay, mass is not the same thing as atoms. Atoms is your clue that you want to be thinking about the little 6.02 times 10 to the 23rd. Okay. Atoms is in the MAPFU, okay? Molecules, atoms, particles, formula units. MAPFU, this is all referring to Avogadro's number, okay? So, I know that Avogadro's number is going to be involved in this problem because it's asking me about atoms. So I'm going to write this all out. 3.42 mole strontium. Oh, I capitalized that. Shouldn't be. Okay, disco down. I'm going to disco down 3.4, or sorry, what am I doing today? I'm going to disco down my unit only. Don't disco down 3.42. Disco down mole SR. We know that 1 mole is equal to how many particles every single time, no matter what? Because that's what we're solving for. Remember, we're solving for atoms. So if you write out your units, that's going to help you figure out what to put next. How many atoms are in 1 mole of anything? That would be Avogadro's number, 6.02 times 10 to the 23rd. Why? It's a constant. 1 mole of anything has that many atoms, particles, MAPFU, right? Whether I'm talking about molecules, atoms, particles, or formula units, it's all that number. 6.02 times 10 to the 23rd atoms. And then we're going to plug it in and go. 3.42 times 6.02. Again, make sure you're good with the EE key or the second EE, depending on your calculator model, or the exponent key. That's all you have to push. Alright, so I'm going to take that out to 3 places. So I'm going to round this to 2.06 times 10 to the 24th. And we'll go ahead and put in another +2 for the word MAPFU, because we want to, anytime we see whether it's molecules, atoms, particles, or formula units, you want to be thinking about 6.02 times 10 to the 23rd. Okay, next page. Here we go. How many moles of sodium chloride are in 7.3 times 10 to the 24th formula units. See what I mean? That's the FU part of MAPFU. So I know Avogadro's number is going to be involved there, right? So if you see formula units, you want to, okay, I know, that's my sign. Avogadro's number is going to be involved here. So this is my given. This is what I'm looking for. I'm looking for the number of moles. Always start with what you are given. 7.8 times 10 to the 24th formula units. I am not trying to curse at you. This is actually the abbreviation for formula units. That's what it is. So just go down your unit. Formula units is my unit. And what are we looking for? We're looking for moles. That's my conversion factor on top, because I know 1 mole is always equal to, no matter what, 6.02 times 10 to the 23rd. And then I'm going to plug it in and solve. So I'm going to solve by taking the number on top, 7.8, EE key, 24, and then I'm not multiplying them, I'm actually dividing them. So you're going to hit your divide, 6.02, EE, 23. There is my answer. And this one, I'm going to round out. Well, I've been doing 3 places, but I'll do it to make it a little easier just for y'all to see. I'm going to round it to 12.96, 12.96. And our answer is going to be in moles. That's what I'm left with, since these cancel out. 12.96 moles. All right. Number 9. How many moles are there? This is what I'm looking for. And 7.5 times 10 to the 23rd. Okay. So here we go. 7.50 times 10 to the 23rd formula units. Just go down your unit, formula unit. Remember, that's my signal. That's the FU in MAPFU. I need to use Avogadro's number. There are 6.02 times 10 to the 23rd formula units in 1 mole of anything. But in this case, specifically, we're talking about sulfuric acid. So we're trying to figure out the total moles. So just like the problem before, we're going to solve it the exact same way. So you're going to take 7.5, EE key 23, divided by 6.02 EE key 23, and you're going to be left with 1.25, I'm rounding here, moles. 1.25 moles of sulfuric acid. We can even be sulfuric acid if you want to be really specific there, which is always good. Alright, so next problem. We are going to do number 14. How many moles of H2S are contained in 35.0 grams? So this is good test practice to give you that multiple choice kind of version of this, what you could expect on your test. Guess what? We solve these all the same way. Box you're given, circle your unknown. Always start with what you are given, 35.0 grams. And I'm going to, grams of H2S, I'm going to just go down, grams of H2S, and I'm looking for moles, so that's what I'm going to put on top. In 1 mole, we need to figure out how much H2S weighs. So that dihydrogen sulfide, how much does that weigh? Remember, we're not concerned with Avogadro's number as far as particles right now, because this problem is not asking me about that. Okay, we've begun with grams, we need grams down here. When you see grams, you need to look at the periodic table. Okay, alright, so there's hydrogen, it has 1.008. We have 2 of them, that's in my formula. So to get the molar mass, we're going to say 2 times 1.008 plus, we have only one sulfur, just one. So plus sulfur by itself was 32.066. And we're going to plug that into our calculator to give us the number to put down here. So I'm going to put that in my calculator. And so my molar mass that goes right here is 34.082. So 34.082. And to solve this, I just need to divide these two numbers. So I'm going to say 35 divided by 34.082. So 35 divided by, and here's what you get. Alright, remember we have to include our units. 1.03, I'm going to round a little. And look at how I rounded, exactly matched choice B. Alright, one final practice question here before we move on to our next video. What is the mass of 3.0 moles of water, which is dihydrogen monoxide, or good old H2O, right? Box are given. This is my given. And I'm looking for the mass. That is my unknown. Okay, so always begin with what you are given. Label everything. Mole H2O. This go down. Bring down mole H2O. In 1 mole, we need the mass. Okay, we're looking for the mass. So do not use Avogadro's number. That's not going to help you. We're not looking for the atoms. We're looking for the mass. So we have to do how we did up here. We need to get the molar mass of water. Okay, so remember, you know you're ready to stop if what you've circled matches what you circled up here. It needs to be in the box, and mass and grams are equivalent. So I just need to find the molar mass of water. So H2O, so H2, so I have 2 times 1.008 plus 1 oxygen, 1 times 15.99, and then I want to figure out what that equals in order to get the number right here. And that is going to give me 18.006 grams. And then to finally solve this problem, I just need to multiply what's on top because I only have a 1 on the bottom. So just taking that 18.006 and multiplying it by 3. And then your calculator answer is this. We can round that and we can find multiple choice D matches what we just solved. So and we're going to do another, just a star and a star and a star and a +2 for our last little bonus point because I can't think of anything else right now. Great job. See you next video.